What if I told you that the United States military has weapons that can travel from Washington, D.C. to Beijing in 30 minutes, lasers that never miss their target, and robots that make battlefield decisions faster than any human commander? These aren't concepts from a distant future. They're operational today, hidden in classified facilities and deployed on secret missions around the globe. The age of science fiction warfare has arrived, and it's honestly more incredible than anything Hollywood ever imagined. Today we're revealing 10 game-changing technologies that are quietly revolutionizing how America projects power across the planet. Hypersonic weapons. The United States Army's Dark Eagle hypersonic weapon travels at over 3,800 miles per hour, so fast it could fly from New York to Los Angeles in just 40 minutes. This isn't just about speed, it's about totally redefining the concept of unstoppable force on the modern battlefield. Hypersonic weapons like the Long-Range Hypersonic Weapon System represent a quantum leap beyond traditional missiles. While conventional ballistic missiles follow predictable arcs that defense systems can intercept, hypersonic weapons maneuver unpredictably at speeds exceeding Mach 5, making them virtually impossible to stop. The Dark Eagle system uses a common hypersonic glide body that separates from its booster at high altitude and glides to its target at hypersonic speeds. What makes these weapons truly revolutionary is their strategic impact. Traditional intercontinental ballistic missiles take 30 minutes to reach their targets, giving enemies time to respond. Hypersonic weapons compress that timeline to mere minutes, creating a new category of warfare where speed equals survival. The Army plans to deploy these weapons in 8 missile batteries, with each missile capable of striking targets over 1,725 miles away. The December 2024 successful test of the Dark Eagle marked a crucial milestone, proving the weapon system's viability for operational deployment. Unlike nuclear weapons that serve primarily as deterrents, hypersonic weapons provide conventional strike capabilities that can be used in actual conflicts without crossing nuclear thresholds. This technology doesn't just change tactics, it fundamentally alters the strategic balance of power, giving the United States the ability to strike any target globally within an hour, while remaining virtually invulnerable to current defense systems. Directed energy weapons. Imagine a weapon that travels at the speed of light, never runs out of ammunition, and can precisely disable targets without collateral damage. Directed energy weapons make this science fiction concept reality, using concentrated electromagnetic energy instead of traditional projectiles to neutralize threats. The United States military deployed its first operational directed energy weapon aboard the USS Ponce in 2014, marking the beginning of a new era in warfare. These systems use high-energy lasers and high-powered microwaves to damage, disable, or destroy enemy equipment and personnel. What makes them revolutionary is their speed. Electromagnetic energy travels at light speed, which is about 100,000 times faster than hypersonic weapons. Current directed energy systems excel at countering drones, rockets, artillery, and mortars, providing cost-effective defense against swarm attacks. A single laser shot costs mere dollars compared to traditional interceptor missiles that cost hundreds of thousands. The Pentagon's roadmap envisions these weapons evolving to counter increasingly sophisticated threats, including anti-ship cruise missiles and aircraft by 2030. Beyond 2030, directed energy weapons will tackle strategic missions like defending against ballistic missiles and hypersonic weapons. Their speed-of-light engagement capability makes them ideal for countering maneuverable threats that traditional defensive missiles cannot intercept effectively. The technology's precision offers another advantage: the ability to scale effects from non-lethal disabling to complete destruction. This flexibility allows commanders to respond proportionally to threats while minimizing unintended consequences. As these systems mature, they promise to revolutionize both offensive and defensive operations, providing unlimited ammunition as long as power is available and reshaping how military forces protect themselves and project power. Autonomous combat vehicles. The United States Army's Robotic Combat Vehicle program represents the dawn of unmanned ground warfare, where machines fight alongside soldiers or independently in environments too dangerous for human operators. These aren't remote-controlled toys. They're sophisticated combat platforms capable of autonomous decision-making in dynamic battlefield conditions. The RCV program encompasses 3 variants designed for different mission profiles: The RCV Light serves as a nimble reconnaissance platform equipped with advanced sensors and lightweight weaponry, capable of deploying drones to extend surveillance range significantly. The RCV Medium bridges mobility and firepower with medium-caliber cannons optimized for infantry support, while the RCV Heavy features robust armor and heavy weaponry including anti-tank missiles and 30mm autocannons for high-intensity combat. What sets these vehicles apart is their integration of artificial intelligence and machine learning, enabling autonomous navigation and adaptation to dynamic combat scenarios. They can perform tasks ranging from reconnaissance and logistics support to direct combat roles without human intervention. The Defense Innovation Unit's ground vehicle. Autonomous Pathways project is developing software that fuses data from multiple sensors, allowing these vehicles to operate in diverse and challenging military environments. However, the program faces significant challenges. Development costs have escalated dramatically, and the vehicle's size and expense make them vulnerable to cheap drone attacks that have proven devastatingly effective in Ukraine. The Army is reassessing requirements to create more cost-effective, survivable platforms. Despite these challenges, autonomous combat vehicles represent the future of ground warfare, promising to reduce human casualties while extending military capabilities into previously inaccessible or extremely dangerous operational environments. Advanced cyber warfare capabilities. The United States Cyber Command operates the world's most sophisticated digital army, capable of infiltrating enemy networks, disrupting critical infrastructure, and conducting offensive operations in cyberspace that can, cripple entire nations without firing a single conventional shot. The United States has developed the most advanced cyber warfare capabilities globally, with Cyber Command centralizing command of cyberspace operations and synchronizing the defense of military networks. The command operates 133 cyber mission force teams, with 41 from the Army, 40 from the Navy, 39 from the Air Force, and 13 from the Marine Corps. These teams conduct both offensive and defensive cyberspace operations worldwide, targeting everything from enemy command and control systems to weapons platforms that, honestly, require computers to operate. What makes U.S. cyber capabilities revolutionary is their integration across all domains of warfare. Army Cyber Command delivers offensive cyberspace effects and electromagnetic warfare capabilities against global adversaries, while specialized units like the 780th Military Intelligence Brigade provide teams for national and combatant command offensive operations. The 11th Cyber Battalion deploys expeditionary cyberspace and electromagnetic warfare teams to augment tactical units with offensive cyber, information operations, and electronic warfare capabilities. Recent developments include advanced cyber threat detection capabilities being evaluated through partnerships between Army Cyber Command and DARPA. These systems can identify and neutralize sophisticated cyber attacks in real time, providing, unprecedented protection for military networks and systems. The true strategic advantage of cyber warfare lies in its deniability and precision. Cyber operations can disable enemy capabilities without traditional military signatures, making attribution difficult while achieving strategic objectives that would otherwise require conventional military force. Next-generation stealth aircraft. The United States Air Force's F-47 sixth-generation fighter represents the ultimate evolution of stealth technology, combining invisibility, artificial intelligence, and drone command capabilities in a single platform that, honestly, redefines air superiority for the next century. The F-47, developed under the Next Generation Air Dominance program, incorporates stealth technologies that surpass both the F-22 and F-35. This sixth-generation fighter features a potentially tailless flying wing design that further reduces radar signature while providing superior speed and maneuverability compared to current platforms. The aircraft's stealth capabilities enable it to penetrate advanced threat airspace that would challenge even existing stealth fighters. What truly sets the F-47 apart is its integration with artificial intelligence and autonomous systems. The aircraft is designed from the ground up to operate alongside drone wingmen through the Collaborative Combat Aircraft program, allowing a single pilot to command and coordinate multiple autonomous platforms simultaneously. This human-machine teaming capability multiplies the aircraft's effectiveness exponentially. The Navy's Parallel F/AXX program promises similar revolutionary capabilities for carrier operations, with 25% greater range than the F-35C and advanced AI integration that transitions from man-in-the-loop to man-on-the-loop operations. This extended range of over 1,700 miles, combined with refueling capabilities, provides, basically, indefinite operational reach. Both programs represent a fundamental shift in air combat philosophy. Rather than single-platform superiority, these aircraft serve as command nodes for integrated air combat systems that blend manned and unmanned capabilities, creating air power effects that no adversary can match with conventional fighters. Soldier Augmentation Systems. The United States Army's Integrated Visual Augmentation System transforms ordinary soldiers into superhuman warriors with heads-up displays that provide real-time battlefield intelligence, night vision, and augmented reality capabilities that fundamentally change how ground combat is conducted. IVAS, based on Microsoft HoloLens technology, represents a $22 billion investment in soldier enhancement. This mixed reality system combines day and night fighting goggles with heads-up displays that integrate next-generation situational awareness tools and high-resolution simulations. Soldiers can see through smoke around corners and receive real-time intelligence overlays that identify threats, friendly forces, and mission objectives directly in their field of view. The system's revolutionary capability lies in its integration of multiple technologies into a single platform. IVAS provides improved mobility and lethality through sensing, mapping, and computing capabilities that enhance mission planning, decision-making, and targeting. Soldiers can rehearse and train in realistic augmented reality scenarios, preparing for specific missions before deployment. Current development focuses on IVAS 1.2, featuring improved form factor, reliability upgrades, and enhanced low-light sensors with distributed counterweight for improved comfort. The Army plans to field approximately 121,500 systems to close combat soldiers, making this technology standard equipment rather than specialized gear. Beyond current capabilities, future iterations may include AI-assisted decision-making, biometric monitoring, and integration with autonomous systems. The technology promises to create soldiers who can process information faster, make better decisions under stress, and coordinate more effectively with both human teammates and autonomous systems. This represents the first step toward truly augmented soldiers who combine human judgment with machine precision and processing power. Quantum computing for defense. The Department of Defense is investing over $100 million in quantum technologies that are set to revolutionize military computing. We're talking about capabilities that could break any encryption, detect hidden submarines, and process battlefield information at speeds that, honestly, make our current supercomputers look like pocket calculators. Quantum computing really represents a paradigm shift in computational technology, one that's going to transform national security and defense operations as we know them. The Pentagon, recognizes three critical applications here: quantum computers for processing vast amounts of data way faster than traditional systems, quantum sensing for detecting enemy submarines and other concealed threats, and quantum communications that offer, unhackable secure channels. The Defense Department's quantum initiatives include the Dakar program, which is focused on testing quantum computing heuristics and exploring near-term applications. Now, DARPA's quantum sensing program, called ROQS, aims to create rugged sensors that can keep their performance even under harsh military conditions. These are already being integrated into space-qualified systems. These sensors, by the way, can detect submarines, nuclear materials, and other hidden threats with a level of precision we've just never seen before. The real military advantage of quantum technology lies in its fundamental properties. Quantum computers could potentially break current encryption methods while, at the same time, providing quantum-resistant security for U.S. communications. The technology enables processing capabilities that, frankly, render traditional computers obsolete when it comes to complex military calculations and simulations. The Pentagon's commitment here also includes establishing a quantum computing center of excellence to strategically scale the technology and build on the momentum that's already underway. This center will focus on quantum computing, integrated photonics, superconducting systems, and trapped ions. As quantum technology matures, it's going to provide the U.S. military with computational advantages that, fundamentally alter the balance of technological superiority in warfare. Artificial intelligence battlefield systems. The Pentagon's generative AI initiative is, creating battlefield systems that can analyze intelligence, recommend targets, and coordinate complex operations way faster than human commanders, fundamentally changing how military decisions are made in combat. Task Force Lima, which is led by the Chief Digital and Artificial Intelligence Office, is synchronizing AI deployment across the Department of Defense to enhance operations in warfighting, business affairs, health, readiness, and even policy. Current applications include intelligent decision support systems and aided target recognition that assist in decision-making, target recognition, and casualty care, all while reducing operator mental load and increasing decision accuracy. Recent deployments really demonstrate AI's battlefield potential. For instance, U.S. Marines in the Pacific have used generative AI chatbots to analyze surveillance data and alert commanders about potential threats. This, honestly, represents the second phase of military AI strategy, moving beyond just computer vision for drone analysis to human-like dialogue systems that can interpret complex intelligence. The technology's revolutionary aspect lies in its speed and processing capability. AI systems can analyze full-motion video that would require human analysts to work 12 hours daily, identifying patterns and threats that humans might miss due to fatigue or information overload. This capability, in turn, expedites decision-making on the battlefield while reducing casualty risk and collateral damage. Looking ahead, future applications include AI systems that not only assess military data, but also recommend actions such as generating target lists. While supporters argue this enhances precision and reduces civilian casualties, the technology, of course, raises important questions about human oversight in life-and-death decisions. The integration of AI into battlefield systems really promises to provide decisive advantages in speed, accuracy, and coordination that no human-only force can match. Advanced Materials Technology. The Department of Defense is developing, revolutionary materials that can stop bullets instantly, heal themselves when damaged, and adapt their properties in real time, creating equipment and vehicles that almost seem to defy the laws of physics. The DoD's Advanced Materials Science and Technology strategy focuses on expediting identification and fielding of materials for defense applications. These efforts span the full materials continuum, from discovery through deployment, targeting engineering problems with multidisciplinary research that establishes fundamental relationships between material structure, properties, and performance. Revolutionary developments include magnetorheological fluids that transform from liquid to impenetrable solid in milliseconds when exposed to magnetic fields. MIT researchers have perfected this technology for potential use in adaptive armor systems that can respond instantly to incoming threats. Meanwhile, Lawrence Livermore National Laboratory has developed fabric from carbon nanotubes that detects and repels chemical and biological weapons. Advanced ceramics like silicon carbide and alumina are being used for armor plates that can withstand high-velocity impacts while remaining lighter than traditional materials. Nanostructured materials exhibit unique properties, including increased strength and conductivity, enabling more efficient sensors, lightweight armor, and advanced energy storage solutions. Smart materials really represent the cutting edge of this technology. Shape memory alloys and piezoelectric materials can change their properties in response to external stimuli, enabling adaptive camouflage, self-healing structures, and energy harvesting capabilities. These materials are just invaluable for defense applications where equipment must adapt to changing conditions. The integration of these advanced materials into military platforms significantly enhances strength and performance while reducing weight and maintenance requirements, providing decisive advantages in mobility, protection, and operational capability. Space-based defense systems. The U.S. military is deploying, constellation networks of satellites equipped with directed energy weapons, hypersonic interceptors, and quantum communication systems that can defend against any threat from orbit while projecting power anywhere on Earth almost instantaneously. Space-based defense really represents the ultimate high ground in military strategy. Current developments include satellite constellations capable of tracking hypersonic weapons, providing early warning, and coordinating defensive responses. The integration of advanced radar systems like the upgraded THAAD and TPY-2 radar demonstrates growing capabilities to detect and track hypersonic missiles from space-based platforms. Looking to the future, space-based systems will incorporate directed energy weapons capable of engaging targets on Earth or in space at light speed. These orbital platforms could provide global coverage with response times measured in seconds rather than minutes or hours. The combination of quantum communication systems ensures these networks remain secure from cyber attacks while coordinating complex defensive and offensive operations. The strategic advantage of space-based systems lies in their global reach and rapid response capability. Unlike ground-based or air-based systems limited by geography and deployment time, space-based platforms provide persistent coverage of any location on Earth. They can simultaneously serve defensive roles by intercepting incoming threats and offensive roles by striking targets globally. Integration with other revolutionary technologies multiplies their effectiveness. Space-based quantum sensors can detect stealth aircraft and submarines, while AI systems process vast amounts of surveillance data in real time. Hypersonic weapons launched from orbit could reach any target on Earth within minutes. These systems really represent the ultimate evolution of military technology, providing capabilities that ensure space superiority translates directly into terrestrial dominance across all domains of warfare. From hypersonic weapons that outrun any defense to AI systems that think faster than human commanders, these 10 technologies aren't just changing how America fights, they're ensuring that future conflicts will be won before enemies even realize they've begun. Each innovation represents years of research, billions in investment, and the collective genius of America's defense industry. As we stand on the brink of a new era in warfare, one thing is certain: the nation that masters these technologies will dominate the battlefields of tomorrow. Thanks for watching Stellar Tech. Subscribe for more incredible insights into the technologies shaping our world. Have you ever wondered what secrets lie beyond our solar system? Bill Nye recently revealed something that, honestly, sent shockwaves through the scientific community. Voyager 1 has detected 300 massive objects floating in the depths of interstellar space. After 45 years of exploration, this aging spacecraft continues to make discoveries that challenge everything we thought we knew about the cosmos. These aren't just random space debris, they're mysterious structures that could hold the key to understanding whether we're truly alone in the universe. Today, we're diving deep into Voyager's most mind-bending revelations. The genesis of Voyager's epic journey. Back in 1977, NASA launched what would become humanity's most ambitious space exploration mission. Voyager 1 and Voyager 2 were originally designed for a simple 5-year mission to study Jupiter and Saturn, but these remarkable spacecraft had other plans. The timing was perfect. A rare planetary alignment that occurs only once every 175 years allowed the probes to use gravitational slingshots to reach the outer planets faster than ever before. What started as a modest exploration of gas giants evolved into the grand tour of our solar system. Voyager 2 became the first and only spacecraft to visit Uranus and Neptune, capturing images that, well, totally revolutionized our understanding of these distant worlds. The mission's success exceeded all expectations, with both spacecraft continuing to function decades beyond their planned lifespan. The secret to their longevity lies in their nuclear-powered systems and robust 1970s engineering. While their computers have less processing power than a modern calculator, their reliability has proven unmatched. Today, nearly half a century later, these cosmic pioneers continue transmitting data from the edge of known space, redefining what's possible in space exploration. Breaking the ultimate barrier. August 25, 2012 marked a historic moment in human exploration. Voyager 1 became the first human-made object to enter interstellar space. At 11 billion miles from the Sun, it crossed the heliopause, the boundary where our Sun's influence ends and the vast wilderness between stars begins. 6 years later, Voyager 2 joined its twin in this cosmic frontier, making them humanity's only ambassadors to interstellar space. The journey to this milestone wasn't easy. As the spacecraft approached the heliopause, they encountered a turbulent region where the solar wind collides with the interstellar medium. This cosmic battleground creates a protective bubble around our solar system, shielding us from the galaxy's harsh radiation. Voyager's instruments revealed that cosmic rays beyond this shield are 3 times more intense than within our solar system's protective embrace. The transition into interstellar space wasn't gradual, it was like stepping from a bustling city into a silent wilderness. The spacecraft's magnetometers detected the sudden change in magnetic field direction, while particle detectors registered the dramatic shift in cosmic ray intensity. This moment represented humanity's first direct contact with the space between stars, opening an entirely new chapter in our cosmic exploration. The mysterious humming of deep space. One of Voyager 1's most intriguing discoveries came in the form of sound, a low, persistent humming detected in the vast emptiness of interstellar space. This cosmic symphony isn't actually sound as we know it, but rather vibrations in the sparse gas that exists between stars. The discovery challenged our understanding of interstellar space as a perfect vacuum, revealing instead a dynamic environment filled with subtle activity. The humming represents the vibrations of electrons in the interstellar plasma, creating what scientists call plasma waves. These waves provide crucial information about the density and temperature of the interstellar medium, helping us understand the conditions that exist in the 99.9% of space that lies between star systems. The consistency of this humming suggests that interstellar space has a more uniform structure than previously thought. NASA's Nicola Fox emphasized the significance of this discovery, noting that no other spacecraft could have made such observations. The detection required Voyager's unique position beyond the heliopause and its sensitive instruments, which continue to function despite the extreme cold and radiation of deep space. This cosmic humming serves as a constant reminder that even in the apparent emptiness of space, there's always something happening. We just need the right tools to detect it. Defying death in the cosmic deep. Voyager's survival story honestly reads like science fiction. These spacecraft were designed to operate for just 5 years, powered by plutonium-238 that, gradually decays over time. As the radioactive fuel ages, it produces less heat, forcing NASA to make increasingly difficult decisions about which systems to shut down. Heaters that were meant to keep instruments warm in the -270 Fahrenheit environment of space, well, those were turned off years ago. Yet somehow, all 5 scientific instruments on both spacecraft are still functioning perfectly. This really defies all engineering expectations and, frankly, puzzles NASA experts who expected the instruments to freeze and fail long ago. The spacecraft's resilience truly demonstrates the exceptional quality of 1970s engineering and the conservative design philosophy that built redundancy into every system. The power situation gets more critical each year, with both spacecraft losing about 4 watts of power annually. NASA engineers are constantly juggling which systems to keep online, always prioritizing the most scientifically valuable instruments. Despite all these challenges, the spacecraft continued to transmit data across the 15 billion-mile void, with signals taking over 22 hours to reach Earth. This remarkable endurance has extended humanity's reach into the cosmos far beyond anyone's wildest dreams. The shape-shifting boundary of our solar system. The heliopause, which is our solar system's boundary, isn't the static barrier scientists once believed it to be. Instead, it's this dynamic, ever-changing frontier that actually moves and shifts like a living organism. Data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer satellite reveal that this cosmic boundary creates unexpected angles and irregularities, really challenging our understanding of how solar systems interact with interstellar space. This discovery helps explain why Voyager 1 and Voyager 2 entered interstellar space 6 years apart, even though they were launched just weeks apart. The heliopause had shifted significantly between their crossings, demonstrating the dynamic nature of this cosmic frontier. Scientists observed the boundary moving at speeds that just contradicted existing models, suggesting that the interaction between solar wind and the interstellar medium is way more complex than previously thought. The implications are, honestly, pretty profound. If our solar system's boundary is constantly shifting, it affects how cosmic rays penetrate our protective bubble and influences the space environment around all the planets. Recent studies published in Nature Astronomy describe these findings as eye-opening, acknowledging that they challenge some fundamental assumptions about heliospheric physics. Future missions, including NASA's upcoming Interstellar Mapping and Acceleration Probe, will help scientists better understand this mysterious boundary. Electronic aphasia in deep space. In May 2023, Voyager 1 experienced what NASA engineers described as electronic aphasia. The spacecraft's attitude control system started sending garbled, incoherent data back to Earth. Like a person struggling to speak clearly, Voyager 1 seemed to lose its ability to communicate effectively, sending random patterns instead of meaningful telemetry about its health and status. The mystery only deepened when engineers realized that, despite the communication problems, Voyager 1 was actually functioning perfectly. Its radio signal remained strong and stable, which meant the high-gain antenna was still properly pointed toward Earth. The spacecraft's scientific instruments continued operating normally, completely unaware of the communication anomaly affecting their host vehicle. NASA's investigation revealed that the attitude control system had switched to a backup computer that had been dormant for years. A simple command to switch back to the primary computer resolved the issue, but the root cause still remained puzzling. Engineers suspect that cosmic radiation or maybe an errant command from another onboard system triggered the switch, highlighting the challenges of operating decades-old technology in the harsh environment of interstellar space. This incident demonstrated both Voyager's vulnerability and its remarkable resilience, proving that even after 45 years these spacecraft can overcome unexpected challenges. Cosmic IT support across 15 billion miles. Managing Voyager's computer systems presents some pretty unique challenges, honestly, challenges that make Earthbound IT support look, well, simple by comparison. These spacecraft operate with technology from the 1970s, including computers that have just 70 kilobytes of memory. That's actually less than a single smartphone photo. Yet NASA engineers regularly send software updates across the 15 billion mile void, and, that process takes over 22 hours each way at the speed of light. The programming challenges here are immense. Engineers have to write code in assembly language, the most basic form of computer programming, because get this, the spacecraft don't have operating systems or any advanced programming tools. Every instruction has to be crafted to work directly with the hardware, which really requires intimate knowledge of systems that were designed nearly half a century ago. And the code, well, it has to be absolutely perfect. There's just no opportunity for quick fixes when the nearest technician is 15 billion miles away. These software updates aren't just, routine maintenance, they're actually lifesavers. Over the years, updates have fixed failing hardware components, optimized power consumption, and even activated backup systems when primary components failed. One critical update actually saved Voyager 1 from potential disaster by activating a fail-safe mechanism when a hardware component stopped working. This kind of cosmic IT support honestly represents one of the most challenging technical achievements in human history. And it's what's kept humanity's most distant explorers operational against all odds. Revolutionizing our understanding of planetary worlds. Voyager's planetary discoveries, fundamentally changed our understanding of the solar system. Jupiter revealed itself as a world of extremes, with hundreds of massive storms, glowing auroras at its poles, and a complex ring system that's even more intricate than Saturn's. The Great Red Spot, which is a hurricane larger than Earth, had been raging for centuries, really showing us the incredible power of atmospheric dynamics on gas giant planets. Saturn's rings, once thought to be simple bands of ice and rock, turned out to be incredibly complex structures with thousands of individual ringlets and honestly, these braided patterns that just defied explanation. The discovery of spokes in Saturn's rings, those mysterious dark features that rotate with the planet, revealed that ring systems are way more dynamic than anyone ever imagined. But maybe the most shocking thing was the discovery of active volcanoes beyond Earth. Io, Jupiter's innermost large moon, displayed sulfur volcanoes erupting hundreds of miles into space, while Neptune's moon Triton showed nitrogen geysers erupting at temperatures near absolute zero. These discoveries proved that geological activity wasn't just limited to rocky planets, opening up new possibilities for understanding planetary formation and evolution. And most intriguingly, Voyager revealed that Europa and Enceladus likely harbor vast oceans beneath their icy surfaces, making them prime candidates for harboring extraterrestrial life. The Golden Record and humanity's cosmic message. Each Voyager spacecraft carries humanity's most ambitious message to the cosmos, the Golden Record. This 12-inch gold-plated copper disc contains sounds, images, and music representing Earth's diversity, including greetings in 55 languages and natural sounds from wind, rain, and animal calls. The record serves as a time capsule of human civilization, designed to survive for billions of years in the vacuum of space. Carl Sagan, who really spearheaded the Golden Record project, envisioned it as humanity's introduction to any extraterrestrial intelligence that might encounter the spacecraft. The record includes mathematical and scientific information, human anatomy diagrams, and cultural achievements ranging from Bach to Chuck Berry. It represents our species' optimistic belief that intelligence and curiosity are universal traits that could bridge the gap between civilizations. The Golden Record transforms Voyager from mere scientific instruments into cultural ambassadors. Long after their scientific missions end, these spacecraft will continue carrying humanity's message through the galaxy. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of the star, Gliese 445, potentially becoming the first human artifact to enter another star system. This cosmic message represents humanity's profound desire to connect with something greater than ourselves, embodying our species' eternal quest to understand our place in the universe. Legacy of discovery and future exploration. Voyager's legacy extends far beyond its original mission, inspiring decades of subsequent space exploration. The spacecraft's discoveries at Jupiter led directly to the Galileo and Juno missions, while Saturn observations inspired the Cassini-Huygens mission that spent 13 years studying the ringed planet. Voyager 2's brief encounters with Uranus and Neptune remain our only close-up studies of these ice giants, though, future missions are planned for the 2040s. Today, both Voyagers continue transmitting data from interstellar space, with NASA expecting to maintain contact until the late 2020s. The spacecraft will eventually fall silent as their power sources decay, but their journey will continue for millions of years. In about 300 years they'll enter the Oort cloud, and after 30,000 years they'll leave our solar system entirely to orbit the galactic center. Current missions like Europa Clipper and the planned Dragonfly mission to Titan build directly on Voyager's discoveries, targeting the most promising locations for finding extraterrestrial life. The spacecraft's detection of subsurface oceans on Europa and Enceladus has absolutely revolutionized astrobiology, making these moons priority targets for future exploration. Voyager's story reminds us that the greatest discoveries often come from pushing beyond our intended limits, proving that human curiosity and engineering excellence can overcome any obstacle the universe presents. From detecting mysterious objects in interstellar space to revealing the hidden oceans of distant moons, Voyager 1 has fundamentally changed our understanding of the cosmos. Bill Nye's revelation about those 300 massive objects reminds us that even after 45 years, these remarkable spacecraft continue making discoveries that challenge our assumptions about the universe. As Voyager drifts ever deeper into the cosmic unknown, it carries with it humanity's greatest hopes and dreams. Thanks for watching Stellar Tech, and don't forget to subscribe for more incredible journeys into the mysteries of space and science. Somewhere in the frozen archives of Moscow lies evidence of humanity's most forgotten triumph, a successful Mars landing that happened decades before the world knew about it. Between 1960 and 1971, the Soviet Union launched a series of top-secret missions to Mars that were systematically erased from history books. While NASA celebrated its moon landings, the Soviets were quietly attempting something far more ambitious, reaching the red planet first. Mars 3 didn't just reach the Martian surface, it made the first successful soft landing in human history. Today, we're uncovering the declassified truth about the Soviet Mars program that the world was never meant to know about.
The Shadow launches.
October 1960 marked humanity's first attempt to leave Earth's gravitational influence and reach another planet. Mars, 1960. A lifted off from Baikonur Cosmodrome aboard a modified R-7 ICBM, but within seconds the rocket veered off course and self-destructed. 4 days later, Mars 1960B suffered the same fate-reaching orbit but never escaping Earth's pull before burning up in the atmosphere. These weren't just technical failures, they were national embarrassments that the Soviet space program couldn't afford to acknowledge. Sergei Korolev, the chief designer of the Soviet space program, had promised Premier Khrushchev a Mars victory to match their successes with Sputnik and Yuri Gagarin. Instead, both missions were quietly reclassified as Cosmos satellites, a catch-all designation used to hide failed interplanetary attempts. Western intelligence agencies only learned about these missions decades later through declassified documents. The Soviet strategy was clear. If they couldn't succeed publicly, they would fail in complete secrecy. The engineers' work was a race against time, battling both the remoteness of space and the limitations of old technology. The successful restoration gave hope not only to the mission but also to
Mars 1, the Lonely Pioneer.
November 1962 brought the Soviet Union's first partial success with Mars 1, a probe that actually escaped Earth's gravity and began the long journey to the Red Planet. Launched during a narrow 26-month launch window, the spacecraft represented a technological leap forward, equipped with a magnetometer, cosmic dust detectors, and instruments designed to search for water vapor in the Martian atmosphere. For 124 million miles, Mars 1 transmitted data back to Earth, proving that interplanetary communication was possible. The spacecraft sent 61 successful transmissions before disaster struck on March 21, 1963. As Mars grew larger in the probe sensors, all contact was lost. Engineers at the Soviet Deep Space Network in Yevpatoria, Crimea waited desperately for signals, but Mars 1 had gone silent forever. The most likely cause was a leak in the attitude control gas tanks, which left the spacecraft spinning helplessly with its antenna pointing away from Earth. Despite the communication failure, Mars 1 proved the Soviets could reach interplanetary space, a crucial psychological victory that fueled their determination to continue.
The explosive disasters.
March 1969 witnessed one of the most spectacular failures in space exploration history. Mars, 1969. A sat atop a massive Proton K rocket at Baikonur, carrying the most advanced Mars probe ever built, a bus-sized spacecraft designed to orbit the planet and deploy a surface lander. The countdown proceeded normally until T+0 seconds, when the 2.4 million-pound thrust rocket erupted into a fireball visible for miles. The explosion shattered windows in nearby villages and sent burning debris across the Kazakh steppes. 5 days later, Mars 1969B met an equally violent end when the upper stage failed during separation, sending the multi-million-dollar payload tumbling back to Earth. These catastrophic failures represented more than technical setbacks. They were existential crises for the Soviet space program. Vasily Mishin, who had taken over from Korolev after his death in 1966, faced intense pressure from the Politburo to deliver results. The twin explosions cost the USSR 2 years of preparation and millions of rubles, but more importantly, they handed NASA a clear advantage in the race to Mars.
Zond 2's silent journey.
Zond 2's silent journey. So, late in 1964 marked another Soviet attempt with Zond 2, a spacecraft that really represented the cutting edge of interplanetary technology. This mission carried experimental plasma thrusters, revolutionary ion propulsion systems that honestly had never been tested in deep space, along with an infrared spectrometer designed to detect vegetation on Mars. For 6 months, Zond 2 flew silently through the void, its experimental systems functioning perfectly as it approached the red planet. The spacecraft's trajectory was nearly perfect, aiming for a close flyby that would provide detailed images of the Martian surface. Controllers at the Soviet Mission Control Center in Kaliningrad maintained regular contact until suddenly, all transmissions just ceased. The probe missed Mars by approximately 1,000 miles, agonizingly close to success. Post-mission analysis suggested either a power system failure or a thermal control malfunction had crippled the spacecraft. Zond 2 joined the growing cemetery of Soviet hardware drifting in interplanetary space, another ghost probe carrying humanity's dreams but unable to fulfill them. Each failure taught valuable lessons, but the Soviets were running out of time and patience.
The M69 catastrophe.
The M69 catastrophe. 1969 was supposed to be the year the Soviet Union finally conquered Mars. After years of failures, Soviet engineers had designed the M69 series, massive, sophisticated spacecraft that would not only orbit Mars but also deploy landers to study the surface. Mars 1969, A, and Mars 1969. B represented the pinnacle of Soviet space technology, each weighing several tons and packed with advanced instruments. The missions were so secret that even their existence was classified until decades later. When both missions exploded during launch within 5 days of each other, it created a crisis at the highest levels of Soviet leadership. Dmitry Ustinov, the defense minister overseeing space programs, personally intervened to prevent news of the disasters from reaching the public. The explosions were so violent they actually registered on seismic equipment, but official records listed them as routine Cosmos missions. These failures cost the Soviet Union more than money and prestige. They cost crucial time.
Mars 2, first impact.
November 27, 1971 became a historic date that, honestly, few people remember. Mars 2, the first component of the Soviet Union's most ambitious Mars mission, screamed through the Martian atmosphere at over 13,000 miles per hour. The lander was equipped with a parachute system, retro rockets, and even a small Prop M rover designed to waddle across the surface on metal skis while tethered to the main lander. Everything that could go wrong did go wrong. The parachute system failed to deploy properly, the retro rockets never fired, and the lander slammed into the Martian surface with the force of a meteorite. There was no signal, no data transmission, just silence from the red planet. However, Mars 2 had achieved something unprecedented. It became the first human-made object to physically reach the surface of Mars. The impact occurred in the Hellas Basin, creating a small crater that remains there today, an unmarked grave for Soviet ambitions. While Western media focused on the failure, Soviet engineers quietly celebrated a grim milestone. They had touched another world, even if it meant destroying their spacecraft in the process.
Mars 3's miraculous landing.
Mars 3's miraculous landing on December 2, 1971, honestly rewrote the history of space exploration in just 14.5 seconds. Mars 3's lander descended through a massive planet-wide dust storm that had been raging for weeks, but somehow, everything worked perfectly. The parachute deployed, the retro rockets fired right on schedule, and the spacecraft made a controlled soft landing on the Martian surface. The first successful soft landing on another planet in human history. Controllers at the Deep Space Communication Center in Crimea erupted in celebration, as telemetry signals confirmed touchdown. For those precious seconds, humanity had a functioning robotic outpost on Mars, equipped with cameras, soil analysis equipment, and atmospheric sensors. The lander immediately began transmitting, sending back the first image ever captured from the surface of Mars. Then, as suddenly as it had begun working, Mars 3 fell silent forever. The transmission, it consisted mostly of gray static with some unclear features, but it represented humanity's first glimpse of Mars from ground level. The Prop M rover was never deployed because the lander died too quickly. Somewhere in the Martian dust, that tiny robot still waits, a monument to Soviet engineering that survived the journey but just couldn't survive the destination.
The cover-up campaign.
Soviet space failures disappeared into a bureaucratic black hole of secrecy that lasted for decades. When Mars missions exploded during launch, they were immediately reclassified as Cosmos missions, generic designations that suggested routine Earth satellite deployments. Vladimir Chelomey, one of the chief designers, created an entire system for burying embarrassing failures behind false documentation. Launch manifests were altered, mission reports were classified, and even the engineers involved were sworn to secrecy under threat of imprisonment. The KGB monitored space program personnel to prevent leaks about failed missions. This wasn't just about hiding technical problems. It was about maintaining the Soviet Union's image as a space superpower. While NASA failures were broadcast on live television for the world to see, Soviet disasters vanished completely from public record. Western intelligence agencies sometimes detected mysterious launches through radar tracking, but without official confirmation, these missions remained ghosts in the historical record. The secrecy was so complete that many Soviet citizens never learned about their country's Mars program until after the USSR collapsed in 1991. This systematic cover-up meant that Soviet achievements, like Mars 3's successful landing, were also hidden from history.
The lost robot.
Buried somewhere in the Martian regolith lies Prop M, the Soviet Union's first Mars rover that never got to rove. This lunchbox-sized robot was designed to crawl away from the Mars 3 lander using metal skis, dragging a tether cable behind it to maintain communication. The rover carried a penetrometer to test soil density and 2 contact sensors to detect obstacles. Prop M was designed to operate for months, slowly mapping the immediate landing area and sending back detailed surface analysis. The rover represented groundbreaking engineering. It had no wheels because Soviet engineers worried they would clog with Martian dust. Instead, the robot was designed to slide forward on twin skis while explosive bolts periodically advanced the device in small hops. When Mars 3 died after 14.5 seconds, Prop M never received the deployment signal. The rover remains locked inside the lander, perfectly preserved by Mars's thin atmosphere and extreme cold. NASA's orbital reconnaissance has never located the Mars 3 landing site, meaning Prop M could remain lost forever. This tiny robot represents humanity's first attempt at mobile Mars exploration, a precursor to Sojourner, Spirit, Opportunity, and Perseverance that came decades later.
Hidden history revealed.
The full scope of Soviet Mars ambitions only became clear after 1991, when classified archives began opening to researchers. Documents revealed at least 18 secret Mars missions between 1960 and 1973, with many more attempts that remain classified. The Mars 3 success was deliberately downplayed even in internal Soviet documents because the 14.5-second transmission time seemed embarrassing compared to ongoing Apollo achievements. Roald Sagdiv, former director of the Soviet Space Research Institute, later admitted that political pressure forced engineers to attempt impossible deadlines with inadequate testing. Each mission failure cost millions of rubles and years of preparation, but the secrecy meant these lessons couldn't be shared with the international scientific community. The Soviet Mars program represented one of history's most ambitious scientific endeavors, combining cutting-edge technology with Cold War desperation. Mars 3's achievement, the first successful soft landing on Mars, remained largely unknown until decades after it happened. Today, as NASA and SpaceX plan human missions to Mars, they're building on foundations laid by Soviet engineers who dared to reach for another world in complete secrecy. The Red Planet conquered the Soviets, but not before they conquered it first. The Soviet Union reached Mars first, landed successfully, and sent back humanity's first surface image. But almost nobody knew about it. Mars 3's 14.5-second transmission represents one of history's most underappreciated achievements, buried by Cold War secrecy and overshadowed by moon landings. These declassified missions prove that space exploration's greatest victories sometimes happen in complete silence. The race to Mars wasn't won by the loudest publicity, it was won by engineers who dared to fail in secret until they finally succeeded. Subscribe to Stellar Tech for more hidden space history that rewrites everything you thought you knew about the cosmos.